In this project, we are going to demonstrate the way to detect brain tumor using MATLAB graphic user interface. So first, we have to load MATLAB GUI. Then open up the space as we needed. And we will use static text to insert our title. Then we can adjust the text box color, font size, style, and color by double clicking the text box. And we will change the background color to gray color. And we will change the foreground color to purple color. And next we will change the title to brain tumor detection. So we will change the font style to classic robot and the font size to 40. So next we will change the background color. So we will change the background color to gray color. Adjust the title to the center. So now we will insert graph axis where our images will be shown later. So double click the graph axis to adjust the parameter, and we will change the color of X and Y axis to white color. Next, we will remove the column and row of the graph axis by changing it to 0. This is the same for both X and Y axis. So next, we will copy and paste the graph box according to the number of boxes we needed. In this case, we will copy 5 of it. Then we will select push button to create different functions. By double clicking the push button, we can change the push button color, font size, style, and color of the push button. So we will change the background color of the push button to purple color and change the foreground color to white color. We will then change the title of the push button 1 to browse MRI image and change the tag to browse MRI image 2. So we can also change the font style and font size. So in this case, we will use classic robot and also 15 font size. Next, we will copy and paste the push button according to the number of push button we need, which is 5 in this case. And next, we will change the title of each of the push button. So the second function will be median filtering, and therefore we will change the title of the second push button to median filtering. And not to forget to change the tag also. And we will change the third push button to edge detection. This is the same for the tag. And next, we will change the fourth push button to segmentation. And finally, we will change the last push button to tumor detection. So after finish creating the program, we will then need to save the program into the document file. So in this case, we will name our program as brain MRI tumor detection. So after saving the program, the script will then pop up in MATLAB program. We will create a function to browse MRI image, and we will use the command global so that we can share variable or images between function and command line. We will use the command imgetFile to retrieve image from our computer, and if the image is not available in the file, an instruction showing image not found will pop up from the window. And here is the command for this step. And next, we will read the image by using the command imread, and convert the binary image to double precision intensity image by using the command imdouble. So since we want to show the image in axis 1, we will type the command axis and those axis, and then our image will be pop up in the axis 1. So for the title, we will name the title as Brain MRI with the font size of 20 and purple color. For the second push button, we will use the function median filtering to remove noise from the image. We will need to type the command global to retrieve the image that we previously used, and to show it in the second axis, we will need to type handles axis 2. So before applying median filtering, we need to convert the image to grayscale image by typing the command RGB to gray, and then we can apply the median filtering function. And next, we will finally label the image as median filtering with the font size of 20 in purple color, and we will show the image by typing imshow command. So the third push button will be used for edge detection. Before inserting function for edge detection, we will use global command to retrieve previous image again. And to show the image in third axis, we will type the command axis handles axis 3, and median filtering function will then be used also. So for edge detection in our project, we will use sober gradient operator. And so here is the script for sober gradient operator for edge detection. And sober gradient operator is actually used to find out the amount of the difference by placing the gradient matrix over each pixel of our image. So we will need to find the sober mask for X direction. And then followed by the sober mask for Y direction. So next, we will find out the gradient of the image. Using the formula as shown. And then we will show the image in the third axis. So we will label the image as edge detection. So the fourth push button will be used for segmentation. Similar as before, we have to retrieve previous image again and type the command to make it appear in axis 4. Then medium filtering function will be applied. So in this project, we will use k-mean clustering algorithm for segmentation, and the following is the script for k-mean clustering algorithm. So this algorithm will cluster or partitions the given data into k cluster or parts based on the k centroids. The algorithm is used because we have unlabeled data. The goal is to find certain groups based on some kind of similarity in the data with the number of groups represented by k. So we will, in this algorithm, we will use morphological operation tool, which is opening operation as seen here, and then we will label the image as segmentation. So the last push button will be used for tumor detection. In this step, we need to convert image into binary image first by using the command im2bw. So in this project, we will use thresholding technique for tumor detection, and the following is the script for thresholding. It will isolate the object of interest from the background, which is the brain tumor in this case. But first, we will need to create a script to define the tumor. In our project, any pixel with density greater than 0.5 will be considered high dense area, and it will probably be the tumor. So here are the script for thresholding. And next, to better detect the tumor, we need to use morphological operation, which is opening operation in this case, to define the shape of the tumor. And we then need to use bboundaries command to trace the border of the tumor. Coordinates returned by bw trace boundary will then be used to plot the border on the image. So we will then label the image as tumor detected, and we will put it in the axis 5. We will then run the program.
Now, let us try the program. First, by clicking on the Browse MRI Image button, we can search for the MRI image that we want to analyze. Then, we get a second image with the noise removed by clicking on the Medium Filtering button. Third, click on the Edge Detection button to get the image which show the edge of the tumor clearly. Next, we can get only the tumor part by clicking on the Segmentation button. Lastly, we can get a brain MRI image with delineated tumor by clicking on the Tumor Detection button. So now, let's try with few other images. This is the second image. Alright. Let's try with the third image. Let's browse for the fourth image. So, this is all about our brain tumor detection program. Thank you.